I want to show you all of the things that you can do to your twin reverbs. If you have one also and you want it to break up easier and you want it to be a little bit lower volume so it doesn't blast you out of the room when it's starting to break up. Hey guys, so the strings in today's final amp demo are brought to you by Kalium strings, and they have a lot of different string types. They have bass strings, they have baritone strings, acoustic and electric, especially if you're looking for some oddball sets. If you want to put together your own kind of sets, wound third, unwound third, you can tell him exactly what you want, customize your sets, and he will send them to you in these customized packaging. So definitely check out Kalium strings, and thank you so much to Skip for sending me today's demo strings. Hey, how's it going, dudes and dudettes? Brad the Guitologist here. Just unpacked this, what I believe to be a 1965 Twin Reverb. And what are the odds of this? I have no idea. But in the packaging, I noticed that this was kind of loose and free. It's the fuse holder that has popped out. And I was like, okay, well, where's the fuse? I looked around the box. I could not find the fuse. And so I got the amp up here on the bench. And I mean, can you see the fuse? What are the odds of that the fuse would end up down in the hole for the bias adjust? That is just about the oddest thing I think I've ever seen in all my years of doing this sort of thing. You can also see there as I zoomed in, I'm sure a lot of you caught the glimpse of the strap that has been added to that transformer right there. That's the choke in this amp, and it's, I don't know if it's been replaced or if it's come loose at some point or what has happened. It looks to me like the straps that it should have come with originally are missing. And I don't know why that would be, but somebody has used these brackets to create a new strap for that. I'm going to presume that's okay and probably not mess with it. So we're gonna get a little closer look at this. I just thought that was funny and interesting. First of all, that's where that fuse ended up. And it looks like maybe the fuse has been blown. The fuse has been blown. I can see it's blown. I have not looked at the problems that it was having yet. I'm gonna have to consult with him here in a bit. I'll call him and figure out what was going on with it and go from there. But obviously it's blown at least one fuse that we can see.
I got that maybe, I want to say 3 years ago. It got, just like maybe new tubes or something like that. But very minimal work. I think under the doghouse, they replaced those caps. But if you look at the internals, it looks pretty original. I'm not worried about that. So whatever you got to do is whatever you got to do. I had it hooked up to my aux box. I had it out in off-grid. I'll run it off a generator through a power, that cleans up the power, and it ran fine, And then I brought it home in Fort Worth, Texas, and maybe on the trip back, it got jostled or something. I'm just going to service this as I would just from the ground up and make sure everything's okay. But I just wanted to make you aware that it does have a blown fuse. It's the best sounding amp I've ever played. I mean, and I was putting it through the UA box, and oh man, because you can do like a wet, dry, wet. It just sounds beautiful. You put a dry cap behind you, and then put the like an alto, those FRs on the side, so you get a stereo effect, and then you got the dry cap behind you. Oh man, it's just perfect. Instead of going to the speaker, straight to the speaker, out of the amp goes into the aux box. Then it does its thing, but then from the aux box it goes back to the speaker for a dry cab, and then there has two other outlets, for left, right, for either front of house or the altos. You can go straight to them off that, and you don't have to put it back into the dry cab. You can have that turned off and just headphone amp it. So it's a cool deal. But I know you had discussed it before about load boxes. I've had people who have run those and experienced problems blowing tubes and things like that because they didn't realize how hot they were running the amp. Because if it's not running into, because a lot of people, they'll have a tendency to turn an amp down
when they realize that I'm blasting everybody out of this room, so they'll kind of cut back, and that usually prevents amps from overheating because they'll run them a little cooler that way, because it's too loud if you're running it normal. But a lot of people, they'll run them so damn hot because they'll start cranking them, and then just the whole time it's running at full blast, and that can cause problems.
I'm glad you made that point, and if anything, let's go a little bit cooler on it. Another thing, when I had it up in Colorado off grid, it's like, I'm almost losing my toes, It's so cold, so it was always running great because it was so cold. And, brought it back to Texas.
And then to Texas.
Yeah.
Right. Okay, so while we're on this side of the amp, let's go ahead and see what's on under the doghouse here. This transformer is loose. Yeah, the screws are absolutely coming loose. Yeah, these are all loose on this transformer. Okay. Oh boy. This is very unusual. It looks like most of these have been changed, but not all of them. General Electric dry electrolytics, man. Wow, you don't see those often. General Electric dry electrolytics. So some of these have been replaced for sure. These are not original, but check it out. So they're Alumalytic dry electrolytics. Man, it's a shame that thing stuck to that because I'd love to read that. Maybe between the three of them we'll see what all's there. So it's 20 microfarad at 500 volts. 550 volt surge, 85C, made in the USA. These are old school. These are from 1965. These might be original. Did they use these? Maybe those are original. This is later for sure. That's a Sprague, and it's a later issue of a Sprague. I think the ones from this era, if I remember correctly, I think those were yellow on the outside. There's a 70 microfarad Mallory at 350, and that one certainly is original. It's 1965 18th week, but these are also dated 1965 13th week. I'm thinking these are original. I don't think anybody would blame me if I went ahead and just changed all of these. And then we've got our dropping resistors here we'll have to test. He said on the phone that he thought these had been replaced before, but nope. I don't think so. Not except for that one right there. That's the only one that's been replaced. So somebody has worked on it, but they basically did only the amount of work that needed to be done and not any kind of preventative maintenance. I only have ever seen really Mallory's under a doghouse on original 60s Fenders. So maybe somebody chime up in the comments. Have you seen, in all your repair adventures, have you seen these General Electric dry electrolytics under the doghouse of an original Fender? Maybe Fender, this is all they could get. Maybe they sold out of a bunch of stuff and ran out of Mallory's, and they used these for a brief run. Here we are on the other side of the amp. A few things pop out at me immediately. One of which is the fact that we have these original 1965 17th week bypass capacitors still in place. We have most of the original blue molded capacitors still in place, with the exception of these 0.1 microfarads down here going into the output. Plate resistors are, I think these are 1 watts, whereas the plate resistors in the other Fender amp we just did were 2 watts. And all of those were spot on when I measured those. We will check these plate resistors, but I'm always suspicious of these 1 watt carbon comp plate resistors in old Fender amps because they just take a lot of abuse. They're running usually fairly hot, and just over time they tend to drift high and then eventually fail. And they sometimes will fail internally to the point where they'll start crackling. They'll start introducing noise and stuff into your amp. So definitely we'll check those, and if need be, we'll replace those with some nicer metal style resistors. Looking down here, we have some replaced grid leak resistors going into the final stage, so those are replaced. We've got a replaced capacitor in the bias supply. On the output, we have all replaced resistors on those sockets. So we have some nice Ohmite 5 watt resistors for the 470 ohm screen resistors, so that's good. We have some little 1 ohm resistors from the cathodes to ground, so you can put your meter on there and kind of get a very quick reading. You can easily calculate plate current by putting your meter across any one of those and see what the plate current is of that particular tube. So that's nice that somebody did that. It's not necessary, but it's nice. We have replaced grid stoppers. Somebody came in and replaced all of those. It looks like at some point somebody replaced one of the sockets. So that tube socket is different from these others, which leads me to believe that one was replaced. Maybe there was a burnout at some point, or an arc or something in a socket. Depth capacitor has been removed on this amp. We do have a hole drilled in the back. I'll show you that from behind here in a second, but you can see there is a jack down here that doesn't belong. God knows what that was for at one point, but it's not hooked up to anything now. So some kind of mod had been performed on it at some point. So we do have an extra hole we can work with if we want to do some kind of mod. We could add the negative feedback control as well if we wanted to. This is a non-master volume twin, so we could actually turn this into one of these into a master volume and one into a negative feedback. So I don't know. As we move along here, I may call this customer and see if he wants to upgrade some things here. If he wants to add a couple of modifications, that would be just sensible mods, considering the fact that this switch is not being used, for one, and secondly, we have a jack here with a hole that could be used for another control, like a master volume even back here on the back, which would be kind of nice, wouldn't it? I mean, if you could crank your channel and then dial down that master volume a little bit and get a little bit more crunch without all of the output. Even if you are running an attenuator, sometimes that's a nice thing to have. But anyway, we'll talk about that. Also, I can see that the roach here has been opened up at some point. You can see it's split. So that tells me somebody has cut into that and opened it up. And then, I don't know, if maybe they changed maybe the light was dead, or the resistor was dead. Okay, so here's the view from the other direction, and it looks like all of the pots are original to the amp from what I can see. I don't see any that look like they've been changed at all. So we'll, of course, clean all of those, as we always do. We'll clean the jacks and all that stuff. That's all a matter of course. But yeah, this is going to be one of those. It's not going to be as simple as the last Fender I did, which if you want to see that video, I'll put a link up here to it. If anybody's counting, I always like to show the serial numbers, just because this also might document things for the customer if he ends up having this thing stolen. It'd be nice to just have a document that you can refer to. It's like, hey, look at this video that was made of my amp. But, like I said, we may end up doing something with that because that's been added. And the fuse, of course, is blown. That's unused, so we might change that to something else. We still got the 2-prong auxiliary plug there. So anyway, that's where we are so far. Let's get started. Okay guys, we're back with this Blackface Twin Reverb, and I had decided early on I was going to try to make it switchable where you could take two of the output tubes out. And the way I was going to attempt to do that was by modifying it to Mesa-Boogie specs, because on Mesa-Boogies they have the Simul-Class wiring. The thing is though, as we've seen in the past with some of Mesa-Boogie stuff, I just really can't trust whether or not the schematics that I'm seeing are correct, because Mesa-Boogie can sometimes pull a fast one. And it looks to me as if the Simul-Class wiring just basically consists of a switch that breaks the grounding on the cathodes of two of the output tubes, and it also does some other stuff. It's not just that. I'm gonna not do that, because it would require us to add some resistors on the output tubes from grids to ground. We would have to change some of the grid resistor values. You know, it's a lot of stuff that really, as an experiment, it's probably not worth doing. However, it gave me an idea. So this guy is using an aux box, which is an attenuator on the output between the output and his speakers, so he can drive the amp at a little bit lower volumes. The idea that I had is to see how much we can get one of these to break up and how easy we can get it to break up without driving someone out of the room. And I think we're going to be able to do that. We've got all the tubes in it, as you can see. We're going to fire it up for the first time here on the Variac. We have our probes on the output going into the dummy load that are going to go to our oscilloscope, so we'll go ahead and turn on our power to everything. So before we get the signal going, we'll go ahead and dial it up a little bit on the Variac and see where we're at with this. And as I dial up any amp that I've been working on, I just want to do it slowly. I don't want to shock it to life. I want to make sure, especially because we've changed some capacitors and stuff like that, so I would just want to make sure that all that's correct. We didn't miswire something, and you know, everybody can mess up from time to time, and you just want to make sure that that doesn't happen. Okay, so we're at what, 53 volts right there. It's gonna be kind of hard to see, I'm sorry. 54 volts, 0.3 amps. We've got light on the tubes. Tell you what, I'm gonna stop right there at about 90 volts, and we're gonna see where it kind of goes. Well, I'm not getting anything. Well, something's obviously not right. I'm not getting anything on the input. I'm seeing a little bit of a DC offset signal here, and it's not, this is not at all what I would expect to see. So I got to figure out what's going on here. This tube is cold. This one's stone cold. So something's not right here. It's got glow, but it is stone cold. Interesting. Okay, so we've got nothing at the output at the moment. Wonder why. Maybe that's it. Maybe I hit the channel switch on accident. Maybe that's the problem. Is that what I did? Yeah, it looks that way. That's exactly what I did. Look at there. Okay. So I hit the channel switch on accident. So we are getting a wave form. We are getting a waveform. I just hit the channel switch on accident, apparently. We've got some distortion going on there, and then when I turn the volume all the way up, it's going into some kind of oscillation or something there, some noise. Don't know if that's a noisy pot or what. But you can see the misshapen waveform. Let's go ahead and dial it up a little bit and see if this hump goes out of the waveform. Now it's getting even worse. Okay. And also there's something funky going on with the bright switch. When I turn the bright switch on, it starts kind of going haywire with the volume control. Yeah, that tube right there is just cold. I think what's going on is we've got a bad tube here, and then we've got another one over here that's working overtime as a result of this one being bad. I'm going to go ahead and kill it, let everything cool down, and I'm going to swap these tubes around. I want to see if the cold tube remains in this socket or if it follows the tube when I move it, and that will tell me whether I've got a tube problem or something in the amp. Okay, so I've swapped these two tubes around, and I want to see if this tube stays cold. We're only at 90 volts. It did not blow a fuse at 90 volts. We've got filament in all four of these. Uh-oh. Got something. Something was going on there. Did you see that? The wattage went way up. Okay, and I saw some spark in that tube right there when I... Okay. Did you see that? You missed it. Watch this tube right here. There it goes. See that? Okay, there's some kind of intermittent short going on in this tube. I was about to say that's the tube that I suspected was the good one of that pair, but it's definitely got a loose element or something in it. I'm going to kill the voltage for a second to the amp, and I want to pull this pair of tubes, leaving only this pair. I want to see how it behaves with just the one pair. We'll come back and we'll test some tubes here in a minute too. Still got a really ugly sine wave. I don't know if it's because I have this thing hooked up weird or what. Hang on. Okay, it's looking a little bit cleaner there. Yeah, now we're back to a really unclean signal, and I don't know why. That probably isn't helping that it's going past all this crap over here. You can kind of see it. Look at that. See what it's doing there? The waveform starts to distort at a point when I'm turning up the volume, and then it goes into this. Okay, so before we go any further, we're gonna test these tubes. And by the way, these are 5881s and not 606 GCs. So, you know, if somebody stuck these 5881s in there and did not rebias for 5881s, it might explain why these might have problems. And as we power it on, you'll see the needle come up. We want to set it so that the test line is right straight up and down. We have the glow in all of these windows right here, the little neon lights. That's indicating that those shorts lights are working. If any of those go out, that means that the tube in question has a short at that particular element. The test procedure on one of these, this is a Hickok model 6000A. This was given to me by a fan of the channel. In the past, I've used a precision tube tester, and it basically just, it kind of checks for emissions, and that's about it. But this is this will check for mutual conductance as well. Plugging this first tube in, I do see a filament glow, but we can hit the filament continuity tester. Well, first of all, let's go ahead and set our line test back up to the middle. Hit our filament continuity, and as long as the needle stays kind of around where it originates, then it's good. If it takes a dive down, that means to replace the tube because there's no continuity on the filament. Now we're ready to hit the test button on this one, and you can see it kind of dive down a little bit. And it is kind of in the questionable territory. Okay. Also, we can test for gaseous condition, and this one appears to be gassy. I believe that's what that means when that dives all the way down. So you're supposed to hold this button, the test button, and then hit the gas button at the same time. And I don't think it's supposed to dive all the way down like that. Let me double check though. Depress the red button marked test and then the button marked gas. The test meter will now indicate the grid current up to 100 microamps. Grid current in excess of 2 microamps is undesirable. If the tube being tested causes the needle on the test meter to move more than 2 small divisions, it should be discarded. Okay, so actually that's a good test. So you want it to go all the way down like that. If it rose past 2, then that would be a gaseous condition. So that is my bad. But this tube is kind of borderline test-wise. There's also another test that this can do. It's called a life test. And to perform this test, we wanted to press the red button, mark test, and then adjust the shunt control until the needle reads at 2000 on the 0 to 3000 microohm scale. And then wait till the needle comes to a stop, hold everything constant, reduce the filament voltage 1 sector. If the needle remains in the good condition, the vacuum tube has a long life expectancy and will perform satisfactorily. I can already tell you that this one being questionable, it's probably not going to pass this test, but let's try it. So it wants us to hold the test button. We want to adjust this shunt so that we get it right up there on the 2000. Now we're going to reduce the filament voltage by 1 step, and we're going to watch this drop off and see if it stays good. If it stays in the good area, then it has a long life expectancy. If not, then it's not. Then it does not have a long life expectancy. It does drop below the good area. It's just a worn out tube. So this tube is a bad tube. It's borderline. It might function in some amps, but it's borderline enough that I would not trust it, and it does not have a long life expectancy according to this tester. So on to the next one. All right, we've got tube filament light, so I expect the tube. So the continuity test, it passes that. Let's go ahead and test it for mutual conductance, and we're not getting anything. I mean, it's dead as a doornail. It's moving the needle a little bit, but not much, like at all. Yes, I mean, this tube is dead. That's 0 for 2 so far. This one has auto, just right away, has shorts. Look at that. Shorts all over the place. I think this is the one that had the lightning in it. 1, 2, 3, 4, 3 different elements are shorted here. Watch this. I'm going to take the tube out again. You'll see the lights come on. It's shorted. That thing is full of shorts. So that's the worst of the 3 so far. This is number 4. So we're 0 for 3 on these tubes. No shorts. Let's see what we got. We do have filament, which I already knew that because all 4 of them had filaments. So we'll go ahead and test it anyway, and that's correct. Okay, we'll hit the mutual conductance test, and we're venturing into good territory. Let's go ahead and hit it with a gas test. Good there. Okay, so this would likely be a good tube. Let's go ahead and do the life expectancy test. So right about there we'll say, alright, then we'll hit it with a lower filament and see how long it stays there, or if it stays there at all. Is it staying good? So this tube is actually the one good one among the 4. So that did not go well. Let's go ahead and test the 12AX and AT7s as well. Okay, 12AX7. I'll walk through this with you as we go. So we want to go up here to 12.6 on the filament. So we've got EV. So there's E, V. Okay, 7, 6, 0, 8, 0. And then we've got a bias of 12. Put that to 12. And then we've got a shunt. It should be at 58. Function A, mutual conductance at 1250. So we've got 2 triodes, of course. So the mutual conductance should be around the 1250. So we're going to be on the 0 to 3000 mark. First AX. Let's adjust our power just a hair. Alright, we've got filament glow. At least in one of them we do. Okay. Thought I saw filament. Well, it's not gaseous, but it's only moderate. It's only moderately borderline. It is reading good, but it's moderate. Let's do the life expectancy test for this triode. So we go up to there, right? And we drop this down by 1 degree, and we'll see if it stays good. And it's not. Maybe. staying in the green, it would probably work. Now let's change the settings for the second half, the second triode of this. So it should be EV, it's the same, 21030. Okay. 2, 1, 0, whoop, 3, 0. And the test is not looking great, is it? Not really. Yeah, this is not going to be a good tube. We'll go ahead and do the life expectancy test anyway. Okay, see the needle dropping, and this one is probably not going to hold. It's, I mean, still going back to the questionable range. It's just a questionable tube. It's not shorted or anything, so it's not like it was causing any problems. But it's not a tube that you would want to rely upon, like I said. Okay, filament on this one's good. Jeez, kind of having to hold it in the socket so it keeps connection because it's losing connection. It's not really the greatest socket, but also it's not the greatest tube, and that much is clear. Yeah, this tube is questionable as well. It's weak, so I don't even need to test the other triode because I know that one triode is very weak. So let's go with this one. This is a Soft Tech. Yeah, already it's doing better than the last one. Slightly, marginally. Yeah, it's marginally good. Gas test, it passes. I guess if we want to, we can do. It's going into the good territory a little bit. We can do the life expectancy test. Might as well. Yeah, weak tube. It's just a weak tube. Yeah, this triode's worse than the other one. Yeah, not a good tube. This one's definitely bad. This one, let's see what we got here. Alright, got a little filament glow. That last tube was even weaker than I was reading it because the shunt wasn't even set correctly. So it was actually way lower on the scale. This one's dead too. Look at that. Yeah, man, this one's dead also. Good Lord. This amp is full of bad tubes. Okay, that one's weak. And this one is weak. This one, the Soft Tech, is big fat G for good. So we had 4 good tubes out of all of those. We had 2 weak ones, and we had 4 that are, including 3 of the power tubes that are decidedly bad. Digging through my stash, I found this nice quad of Magnavox labeled but Sylvania made 7027As, which are a 6L6 GC equivalent, but they have more plate dissipation, 35 watts, as opposed to the 6L6's 30 watts of plate dissipation. So it's a more robust 6L6 essentially. And I think I've already tested these on the Hickok, and these test really nice. They've got a lot of life left in them, even though they're pulls. I'm going to be able to give this guy a pretty good deal on these, but that also does mean we're going to have to rewire the sockets just slightly so that the pin 1 is freed up. They're using pin 1, I think, as a tie point. I'll have to look at it closely, but we may have to modify the sockets ever so slightly to get these to work. But that's not something that's undoable later on if you wanted to, but you never would really have to, because you'll be able to still drop 6L6 GCs in as replacements. So one beneficial mod there. I've also got a whole stack of some preamp tubes. We're going to do some preamp tube rolling at some point on this and kind of figure out something that works really nice in the V1 and V2 positions. At any rate, we're going to go ahead and start on the mods on this amp, and we'll be able to pop these tubes in. Okay, if I was gonna do the mods for the Mesa-Boogie style Simul-Class, now would be the time to do it because we have to change some of the grid resistors anyway. If we look at this schematic that shows their Simul-Class switchable output from a Class A push-pull with 2 tubes to a Class AB with all 4 tubes working. And they do that with a switch which disconnects the cathodes from ground on 2 of the tubes only. This middle pair of tubes. You can see the switch right here. So when the switch is thrown, it basically cuts the power down in half, more or less. But the thing is, if we wanted to do this like Mesa does it, we have some stuff we're going to have to change. We have a 1 meg resistor right here that is a grid leak resistor that goes from the grid of the 2 tubes that remain on at all times to ground. So we've got one on this side and we've got one on this side. We would have to add those to a Fender Twin. Also on this side we have a 221K resistor here. It says 2.2K on 100 watts. And then this is, you delete this on 100 watts. Yeah, it's confusing the way they've got this notated. When they make a notation like this, 2.2K on 100 watts, it makes me think that maybe they are actually switching, because I don't have a Mesa in front of me to really go in and see what they're doing. So it makes me wonder whether or not they're switching this resistor at the same time that they're taking this one out whenever this switch is thrown. Like it does more than just throw this, but it turns all of these, it changes all these various resistors as well. Like takes these out of circuit. I'm not sure if that's the case or if these remain. I just don't know. So I'm thinking that this is, until I can research this further and figure out exactly whether or not this is something viable that I can attempt here, and maybe do more experiments on an amp that's mine instead of a customer amp, I don't think I really want to try it. So unfortunate as it is, we're gonna have to abandon the Simul-Class idea for now. Okay, so here's the first mod done, and you can see all I've done essentially is lift these grid resistors off of the pin 1 and just move the wires up and out of the way of everything and over to the next grid resistor. Next mod we're going to do is we're going to put a post-phase inverter master volume on this. Okay, so for the master volume on this, we are going to refer to what's called the Trainwreck pages by Ken Fisher, and he outlines some different master volumes. We are going to use Type 3 master volume, which is the simplest to install and it only requires a single 1 meg audio taper potentiometer. We are going to do this and put the potentiometer, I think, over here where the switch was for the ground. So we're going to remove this ground switch and we'll reorganize these wires that are attached to it right now. The other mod that I considered on this possibly is a presence mod. Now the reason being, rather than just a simple negative feedback mod, which we could do, we could elaborate on it and upgrade it to more like a sort of a Bassman style presence control. And if we do that, we will probably stick it over here where this hole currently is. One more mod that I discussed with the customer and he's on board with is the inclusion of reverb on the normal channel. So a lot of players, in order to get more gain out of an amplifier, will jumper channels if it's a 2-channel amplifier. Like this one, for instance, and all the Blackface Fenders do have 2 channels, of course, a normal and a vibrato in this case, and it has 4 inputs. Just like the old early 70s and late 60s Marshalls, the plexi faces and also the metal face type Marshalls that had 4 inputs stacked, you'll often see players, they will plug into one of those inputs and then they'll take a jumper wire out of one and then go to the other channel. That's called jumpering channels. Well, on an amp like this, on this Twin Reverb, you cannot do that, and I'll show you why. Because if you tried to do that, you would actually cancel the phase and it would diminish the output overall rather than increase the gain like the goal would be with doing something like that. The reason that happens is because if we look at these inputs here and we count the stages, we have on the normal channel we have 1 stage of gain, and then it goes through tone, and 2 stage of gain, and then it goes from there over through this capacitor and bypasses this stage of gain right here. However, on the vibrato channel, we have this stage of gain, this stage of gain, and then we go through an additional stage of gain. Also on the vibrato channel, if you're using reverb, you will go through all of this and then tie back here as well through this additional stage of gain. If you were to try to jumper these channels the way that they are right now, you would find that these are out of phase with one another and they would cancel. So what we're going to do is we're going to take this normal channel where it comes out right here, and we're going to put some circuitry in where we can actually, instead of tying this over here to the phase inverter stage, we are going to tie this in so that it utilizes this stage of gain also, which will put these two channels in phase, which will allow you to jumper channels on this. And since his goal is to be able to rock this amp up, because he's using it kind of in a studio setting, and he wants to be able, right now he's using an aux box to achieve all of this, but the goal here is to give him more flexibility, where in situations if he doesn't have an aux box or he doesn't want to use the aux box constantly, he can get more of the organic sound of the amp without using that. He'll also have more flexibility in the amp overall, because he'll be able to jumper these channels and get more gain out of the thing. So this is a completely undoable mod, but it's one that's pretty easy, and it's also going to give the amp the option of using reverb on both channels. So because we're going to tie the normal channel in here, just like this vibrato channel, it also will go through the reverb section. Okay, here's another example of a power cord that's wired incorrectly. This power cord has been replaced, and the hot wire that's coming in is coming into this point right here. It's this brown one. If you follow this out, it's going to here, and then it's going to the sleeve of the fuse, which is really incorrect. You want the hot wire to go here first, so that when you have the fuse out, you can't really stick anything in there and get to the sleeve, because the sleeve is the most accessible terminal on this, and you don't want a chance for the hot to be plugged in and some little kid come along and stick their finger in there and get electrocuted. Okay, flash forward a few minutes and I have this wired correctly. So what I've done is I've taken the wire that comes in here, and I've run a single wire over to the tip of the fuse holder, and then coming out of the sleeve of the fuse holder, it then goes over to the switch, one side of the switch. On the other side of the switch, it goes through the transformer primary, and then on the other side of the same transformer primary, I just got rid of all the other wires. I actually had a couple of extra ones that came off of there. Didn't use them or need them, because this wire is plenty long. Just use this wire to go directly here to this tie point. This is the way really that a Fender 3-prong cord needs to be wired. Now we can just remove this switch because it's not being used for anything else, and we're going to put our I really haven't decided yet. I think I'm going to put the master volume control right here in this position. Okay, now we're going to install a presence control in this amplifier, and to do that we're going to model it after the Fender 6G6 Bassman. The 6G6 Bassman has a presence control that basically was stolen by Marshall. We have a negative feedback coming off the output. We have a 100K resistor right here. If we look at the original schematic for the Twin Reverb, we could see coming off the output in this position, we have a resistor of 820. That then goes on down here to a resistor of 100 ohms to ground. Okay, and compare this setup with an 820 and a 100 ohm resistor to this setup with a 100K resistor and a 4700 ohm resistor here. And also around this 4700 we have a 0.1 microfarad capacitor in series with a 25K presence control. The way this is generally set up in the Bassman is inside of the amplifier we have the negative feedback coming off the speaker comes up here, goes under the board, and then goes to the 100K resistor here, and then comes to this point, heads over to the presence control. We have a 4700 to the back of the pot on this leg, and then we have these two legs tied together, and then a 0.1 microfarad capacitor to the back of the pot there. Okay, that might work fine in the 6G6 Bassman, but in this amplifier, here's our 820 ohm resistor. Then it goes to this point where everything else at this junction is connecting, and then we have the 100 ohm resistor over to a ground point here, which is then going to ground. So to keep everything in order in terms of where the grounding scheme is, because we're having to put the control way over here, we're going to run two wires in this instance. So what we're going to do is we're going to replace this 820 as we see in this schematic with the 100K that we see here. So we're going to replace this resistor here with a 100K. This one we're going to replace with a 4700, and then we're going to run a couple of wires. We're going to run one wire off of this point over to the control, and then we're going to run another wire back to this side to go to ground, because we want the ground to end up at this point. So let's go ahead and install that, and then I'll show you how that looks. Okay, so the presence control mod is now complete, and we can see what was done here. So I changed this resistor here from an 820 ohm resistor to a 100K. This resistor here was changed to a 4700 ohm. I have a line that's running from this side where these two resistors meet all the way under the board right here to this lug. That's if you're looking at the back of the pot. It's the one on the right. I have the wiper attached to the other leg, and then on this side we have a 0.1 microfarad capacitor, and then it runs back this way to this point, which is the ground point. The reason I ran those two wires, whereas in the original Bassman design you only have the one wire that's going to the pot, is because, like I said, I wanted to ground that over here and not have the ground be way the heck over there, because I thought maybe it would set up some kind of ground loop. I just did not want to get into that. If you put something way back over here, you're likely to possibly start introducing noise that we didn't intend. So that is that modification done. So we have the master volume, we have the presence control. Now we have to go and do the mod for the channel mixing. So coming out of the normal channel, the second stage of the normal channel, coming off the plate right here, we have a 0.047 capacitor and a 220K resistor right here, and then that proceeds on past this stage to this point. We want to sever this connection, so we want to get rid of this wire that's running between the 220K and this point, and then we're going to bring this wire down here and tie it in somewhere like right here. Now if we look at this other channel, the vibrato channel, it has the two stages. Coming off this the plate of this second stage is a 0.02 capacitor, and then it just goes directly into here. We have to put some kind of resistance right here in order for this to mix correctly. Some of the signal is going to end up getting lost down this pathway if you don't have something that's blocking it from wanting to go that direction. We want the reverb and the trim to be usable on the normal channel too. We are going to sever the connection right here also, so there won't be a connection between this point, and we'll mark another point right down here, say, and then we're going to come around this and connect that right there as well. So we're going to have to sever this connection. The 0.02 will go through probably a 220K, because that's what we had up here, basically blocking signal. When you're playing on the normal channel, signal's coming through this wire to this point. It's going to see 220K of resistance right here, and it's not going to want to go that way. So there is a tendency for the signal to come down this way and take this path through the reverb and everything. Yeah, so we're gonna do these mods like this, and this is gonna, I'm gonna have to find all of these points too. The thing is, okay, so the 0.047 capacitor in the actual amp that's coming off the normal channel is this guy right here. Okay, so on the other side of this, you'll see it kind of goes to nowhere, but the thing is, there is a connection, this blue wire, and if we follow it down, it eventually ends up way down here. It keeps going, ends up way down here, this blue wire, right here, and there's our 220K resistor right there on the normal channel. So you could see it's bypassing all of this stuff in between because it doesn't need to use any of this normally, and comes way the heck down here. There's that channel. Now this other channel, so the second plate of V2 comes to this point, and our 0.02 capacitor, this ceramic. That's the second capacitor in the second channel. We're going to have to sever the connection between this 0.02 capacitor and this capacitor right here, which is a 500 picofarad. That is going to be this. See these two capacitors right here together? So what we've got to do is lift one of these legs on one of these. So we'll go ahead and lift that leg on this side right here where those connect, and we're going to leave all the other connections that are there. So we're going to leave that capacitor there because it needs to go ahead and connect where it normally did. But all we need to do here is lift this leg, and we're going to put a 220K resistance between that leg and right there. But this is just going to be a way more versatile amp at the end of the day. So we've got this normal channel signal coming through this capacitor to this point, coming up on this blue wire again, coming way down here. So on the other side of this, we need to lift this leg of that resistor way down here. Alright, we need to go from this resistor now, another cable run, all the way back over to this point right here where we tied that 220K in. It needs to tie in right there. I'll just pop a piece of this big bright standout red wire. I need to come down to here. I want to leave a little bit of extra so I can wind it around this existing wire. So we'll cut it right about maybe there. We'll tie it up here in the air as well, like we did the last one. Alright, and that's very simple. Very simple yet very effective mod that's going to have a couple of different really huge benefits on a Fender. For all you guys, especially on twin reverbs, who complain that the twin reverb has a hard time breaking up, this is going to help solve that problem. Yeah, I think that's going to do it for the mods. Okay, we are now to the point where I have a complement of tubes populated here, plugged into our oscilloscope, and our signal generator is coming in the front end. Let's go ahead and power on the Variac, and we'll start dialing it up here and make sure I don't have anything in the way. We're just going to bring it up slowly because I don't know where the bias is really set. Now these tubes are 35 watts plate dissipation each, so they're actually more robust than your typical 6L6 GC. Alright, let's see if we've got anything here. What was that? What was that? Did you see that? I gotta play that back. What was that? Okay, so that was interesting. I looked back at the footage, and the problem was right here on the cathode of this third power tube over from the left. So this one right here, this cathode arced somehow. I don't know if it arced between the cathode. See, somebody added these resistors, and maybe it's just not getting a good enough connection between there and ground. It was really interesting because you could, there's a few hairs and things in here too, and you could see in the footage that some of these hairs, like right before the spark happened, that some of these hairs actually lifted up, like it sensed the incoming magnetism, or static electricity, So some of these little hairs that are kind of in here started lifting up and stuff. That's wild. Let's make sure that resistor's all right. Well, okay. I'm not getting jack. That resistor appears to be open. From here to chassis, I should see about 1 ohm, because that's what they've got in here. But I'm not seeing 1 ohm at all. I think that resistor popped open. It did. Sure did. Hell, that one's drifted up. These are 20% resistors. These are not. Okay, I think I'm gonna get rid of all 4 of those resistors because they are not accurate anyway. These are like 20% accuracy resistors. I'm just gonna delete these. All of these. They're really only there so that someone could easily put a probe between them and get an estimate of what that particular tube is, because using Ohm's law, you could do a real quick calculation of what this tube is drawing current-wise. But with it as it is, these aren't going to be accurate anyway, so it's going to throw off any measurement you think that you're getting, especially when one of them is obviously open now. Okay, ladies and gentlemen, it's confession time. So I completely screwed up here. So when I looked at the pinout for the 7027A, I knew that grid 1 usually is a no connection on a 6L6, right? What I failed to see from the pinout charts on the 7027 is this difference. And this is completely my fault. I looked online. I saw discussions on forums about the 7027, and they were saying, well, the pin 1 is different. Everybody was like, pin 1 is different. So I was thinking to myself, okay, so pin 1 is different. And I realized that. You could see that right away. Pin 1 is actually connected to grid 2 on the 7027. The problem is right here with pin 5 and 6. Both pin 5 and pin 6 are connected internally to the grid, and the problem with that is pin 6 is right here, and they're using that as a tie point for this resistor, and I just completely whiffed on that, man. I completely didn't see it, first of all, on the pinout, so that was my bad. And nobody in any of the forums that I saw was mentioning it, so it didn't draw my attention to it. But that's what you get for reading forums and not paying attention and looking at the pinout yourself. That should not have escaped me, and it did. So 7027s are out of the question here. I've gone ahead and returned these sockets back to 6L6GC because these will never accommodate 7027s without moving this leg right here on the pin 6 for each one of these tube sockets, and I'm not going to do that. It's really not worth the effort because you would have to move those off onto a separate terminal. This leg would have to have its own terminal, really. And in order to do that, you would have to, drill holes in the chassis, put 1, 2, 3, 4 terminals over here, and it's just not something I'm going to be doing. So we're going back to the original plan. Okay, so I've skipped forward a little bit on this project, and where I've arrived at now is I have installed a quad of these Russian, they're not 6L6GCs, they're actually more like 5881 kind of, but these 6N three Cs. These are Soviet era Russian tubes. I have a quad of them in here. They are 20 watts or thereabouts maximum plate dissipation, so I'm you know, biased it accordingly. Yeah, I think that's going to actually tame down the output a little bit, and will be a better solution than 606 GCs anyway, if you not want this thing to be overly loud. So we're going to go with those tubes. Also, I have decided to do another modification on this. I'll talk more about that other modification after it's completed, and I can show you what's going on with it. But it's going to require me to move this presence control that I had back here. I'm going to actually move it to the front, and I'm going to put it right here in the vibrato channel jack number 2. And like I said, there's a good reason for that, because what I'm going to put back here needs to be right here beside the reverb anyway. Essentially what it's going to be is a reverb bypass control. They made a device back in the 70s. It was called an ice cube. Well, they made a couple different versions. They actually had an ice cube and a super cube, I think, were the two that you could get. And they had these RCA jacks, and basically it was a piece of a little plastic housing with the RCA jacks installed, and it just fit directly on the back. And one of them, the super cube, actually had an adjustment. The other one was just basically almost a dead short, but I think they had a resistor there that was kind of helping with the load handling. But at any rate, I'm going to do the potentiometer version of that, more or less, and I'm going to put it right here. We had this existing hole anyway, and I can't really think of anything better to be right there in that spot than that mod, because that's really going to rock this thing up. And that's something he's going to always be able to kind of reach back here and blend between all reverb. So basically he'll be able to turn the pot all the way down and get just the stock sound, the stock reverb tone. But he'll also be able to dial in this pot, and what that's going to do is it's going to gradually short between the input and the output of the reverb jack. And the more that you do that, the more you're actually sending just raw signal through the reverb circuit, which is really going to overdrive this amp. For now, we're going to take out this second jack right here, and we're going to move this potentiometer up to this point. Okay, we're back with this thing, and all the mods are complete. I've moved the presence control up here to the front. Presence doesn't have a whole lot of effect unless the master volume is really high. If it's all the way up and you're on clean, then the presence has a lot of effect, and you will hear it for sure. If the master volume is very low, like bedroom volume, then the presence doesn't really do very much. Okay, so we got the reverb bypass boost control also wired in. This is a 1 meg pot. This is actually a really easy mod, and it's definitely one that I recommend. This 1 meg pot is just, you're shorting this jack to this jack, and you're doing it kind of gradually. Now, I made it I could have gotten away with maybe like a 500K pot, or even like a 330, something like that would have been fine too. I made it 1 meg because I want to ensure that there's enough resistance that I'm not losing anything when I have the control all the way down. So, but this thing really screams now, and you'll see what I mean here. Okay, so this is going to be really kind of a noisy test. I'm just using a speaker that's out here on the desk. Here, I mean, maybe you can even see it. There you go. See, it's in the box. So it's not going to have a full cabinet sound or anything like that. So typical twin reverb right there, right? But if I turn down the master volume, crank both of the channels, right? With me so far? And now bypass the reverb with the overdrive control. Let's see what I mean. It's pretty randy. Now I'm getting a lot of extraneous noise and stuff because I still need to, like this pot right here is kind of dirty and it shows. Also, I haven't cleaned really anything yet. I haven't cleaned any of the pots. And I have not hand selected any of the preamp tubes either. You know, I'm going to go through and hand select a couple of great preamp tubes for him to put up front in V1 and V2. So we still have that left to do, which will improve it even further. And plus, we're out on the desk. We're getting a lot of extra noise. But I mean, for a Fender Twin Reverb, right? For a cigar box guitar too. Okay, and just because most of you guys probably have never had much experience with these Soviet tubes, you know, it's in Cyrillic. It's supposed to be 6N. It looks like 6N 3C on the actual tube, but I think it's in Cyrillic. It translates to 6P 3C or something like that. I don't know. We're going to take a look at the waveforms that we're getting over here. You can see it's really squared off right there. This is turning the reverb up and down there. You can see what that's doing to that waveform. Really just rocking it up. Now there will come a point when it becomes unstable and goes into oscillation. See that right there? It's way too much. It's actually pushing the amp too far as well. So what we're just going to do here is we're going to push it up to the point. I'm going to set it to normal here, and we're going to push it right up to the point of turn the master all the way up, and we'll push the pre right up to the point of overdrive, and we'll look at the crossover distortion notch. Right there's where it squares off, so I back off of that a little bit, and you can see the waveform looks pretty good. There may be a little hint of a notch there, but I definitely want these. I want to give these tubes a good chance of survival, so I'm not going to push it. But that right there looks pretty good to me. It's not until it really squares off that you start to get a little bit more of a pronounced notch. So I'm going to say that right there is looking pretty good. Now let's check out the numbers. We've got at idle. We'll set it back to idle here. So we'll say 449 times 0.03. So we're up to 0.03 right there, which equals about 13.5 watts per tube, which is below the 70% mark. Like I said, these tubes, I believe, from what I've seen, are rated about 20 watts, and that would make 14 the 70% mark. So we're good as far as 70% goes. Okay, so this portion of the video, I'm just going to use the on-camera microphone because it'll be a little bit simpler to do this. So pretty much this is a stock Fender Twin Reverb, believe it or not, with a couple of modifications. But the modifications are completely undoable. If you turn the master volume all the way up, if you turn the Reverb Bypass Mod all the way down, you're basically in stock Fender mode, with the exception of the presence. But once again, if you turn that all the way down, you are back within stock Fender Twin Reverb mode. Also, I've only got 2 output tubes running at the moment. and that can be changed as well. Just add the other 2 power tubes, and as a matter of fact, I mean, I could have been playing with 4 the entire time. It wouldn't have made much difference. It does lower the volume somewhat, so it's just a little bit easier for recording. The only other mod that I did was to make it possible to jumper channels, which really only increases the flexibility of the amp. Let me give you a quick rundown as to, you know, how you can start to get sounds with this thing. So, you know, obviously we've got the real clean. So there's our Fender regular twin reverb sound. Right now I'm only using, well, mainly 1 channel. I've got this volume on this channel all the way down, so we're really only using this 1 channel. If we start to add in the other channel, we can start to drive that front end. Of course, it's way too much reverb for that, so we're going to turn down the reverb. You start to crank the mid-range, you start to get more of that marshally crunch. Now with the master volume all the way up, again, you know, you're basically in stock Fender Twin Reverb mode. But if you start to reduce the master volume, then you can drive these channels even further without overdriving the output. You can get more of a preamp sort of sound crunch. So now the channels are both cranked. With the presence control, you'll notice that it is more effective when you have the master volume up a little bit. If you turn the master volume way down, the presence control doesn't do a whole lot because there's not as much on the output that's going to be able to feed back in and cancel out signal. So it's not as effective unless you got the output all the way, basically almost all the way up or halfway to all the way, and then the presence control will start to show more effect. Okay, so the channel volumes are cranked at the moment. If you want more distortion in that tone, you can start to bring in that reverb mod. And there's a point at which the reverb mod will start to actually work, and you'll hear that change. You hear the change between those two. Okay, now it's on and ready to work, but we have to dial it in with the reverb control. And right now the reverb control is all the way down. So if we, let's go ahead and turn the master volume down a little bit. Now that's the bedroom volume basically. You can probably hear my string noise louder than you can hear that. So really low volume, but still driving and still sounding pretty. And a lot of the tracks that I recorded for this demo were recorded with this really low like that. Now the camera microphone is set to auto, so it has a compression effect. So when I start talking, it's going to turn down my talking and it's going to raise this up to meet the level. But you'll kind of notice that when the compression on the mic kicks in and when it doesn't. So, but take my word for it, this is bedroom volume. You can jam this with your wife asleep in the next room and she's not going to wake up and bitch at you. kick in that reverb bypass effect. Did you hear that happen right there? Okay. So anyway, that is a 1965 Fender Twin Reverb, which has been heavily modified and now pretty much can achieve just about any tone you want, all the way up to 80s and 90s heavy and even death metal. So if you like this video, if this is something that you would want to try on your own, let me know down in the comments below. Also, make sure to subscribe. Meet me over on my locals page if you want to see more behind the scenes stuff and more posts over there. But for now, we will see y'all later.